All right, in this video, we're going to take a look at the mean and standard error for proportions, for sampling distributions of proportions. So recall that the mean and standard deviation of binomial probability distribution are going to be the mean is the number of trials times the probability of success, or n times p. And then the standard deviation, sigma, is the square root of the mean times the probability of failure. Or in other words, the square root of n times p times 1 minus p, in parentheses for the 1 minus p. So we can think of a proportion as n representing our sample size and p representing the probability of success, or the proportion or percentage of items in our distribution that are accounted for. So to obtain the mean and standard deviation of a sampling distribution of proportions, all we're going to do is take our mean and standard deviation here and divide them by the sample size, n. So when we divide the mean, n times p by n, the n's cancel out, we get the mean of our sample proportions is going to target or equal the population proportion. So much like the sample means target the population mean, the sample proportions target the population proportion. So our sample proportion is denoted with a p with a little hat on top of it. So that's a pretty common notation for that. And then lowercase p here is our population proportion. Our standard deviation, if we take the square root of n times p times 1 minus p and divide it by n, through a little bit of algebraic manipulation, we'll end up with the square root of our probability of success times our probability of failure, all divided by our sample size. So to go from this part to this answer here, we could do a little bit of algebra and dividing by like radicals and things of that nature. But the standard deviation for a sampling distribution of proportions, again, is the square root of the probability of success times the probability of failure, all divided by the sample size. All right, so example 6, we have a headache medicine claims to be 80% effective. What is the probability that in a sample of 400 people, the medicine is going to be somewhere between 75 to 90% effective? So we have our population proportion is 80%, or 0.80, because that is what the manufacturer is claiming, that it works on 80% of the people who take it. And for our standard deviation, if we take 0.8 times the probability of failure, which is 0.2, and divide that by 400, and then take the square root of that result, we get about 0.02. So about a 2%, or exactly a 2% rather, standard error for this headache medicine. So let's fire up the normal distribution calculator with we have our values here between 75 and 90, and then our mean and our standard error, which is going to be our standard deviation. Alrighty, so we are working with observed values, so we'll go option 2. And we're trying to find an area, so that's option 1. And we want the area between two values. We want the ones between 75 and 80, so we're going to select option 3. And the smaller observed value is the 75%, so I'm just going to enter that in as 0.75. And the larger observed value is 90%, so that's our end point. Our mean, again, is 0.80 or 0.8. And then our standard deviation is 0.02. And we get a area between 75% and 90% is 0.9938. So our area between there is 0.9938. So in a sample of 400 people, there's about a 99.4, 99.38% chance that the medicine is going to be between 75 and 90% effective. So very, very high probability that between 3/4 and 90% of the people in our sample are going to feel the relief from taking the headache medicine. So very high chance. So that's reassuring. All right, that about does it for this video. Thank you for watching. I'll see you next time.